Digitalist. And how do we do this? Why do we do this? We run our thinking as a company very holistically. Designers always do that. Design thinkers always do that. If you read our strategy statement, it says people, planet, and profit, and in that order. People first, planet, then we try to make good business in that context. And that's also, we have a very glass box type of an approach to the world. You know, the clients that we work with, we share a lot of our methodology. It's reusable. Everything that we do, we're also seasoned, so professional that we realize, technology-wise, when we share, we always get more back. Both also in terms of experience-wise, the more we share, we get more back. It happens over a long time, sometimes over a very short period of times. That's why we drive these users, designers, partners, us, Digitalist events. We do them all around the world. We had the pleasure to have this gentleman that is eagerly here waiting to get on the stage with me, Kyle Honso, in Vancouver on Tuesday. Kyle is our machine learning engineers. We were doing this on Tuesday in Vancouver, last month just in Stockholm. Then Helsinki had a couple of ones. This is actually the same night. London has already gone to bed, but we had a big kind of a launch event and Digitalist event over there in this same day. Good. With those basic things, I actually welcome Kyle on stage with a big hand. Shall we give always a big hand? Yes. Thank you.
Thank you. I think I have a different. There we go.
That's this deck one. Yes.
We might have heard enough about Digitalist.
I think we did. No, we're not going to go. Everybody knows us. And the ones that didn't get enough of us, you know, then you all check on the digitalist.global and see our website and see some of the cases that we work on and so on. Because we want to get into the, how do we actually work? How is this interesting? Because the subject of this evening is actually extremely hard. If there is someone on the audience that really knows how the future of machine learning will match into like holistic design thinking and human behavioral, raise your hands. Hey, there's one. There's Mika. Yeah, he works on that one every day. He works with us. Yeah, we have a couple of them here in the front. Good. Challenge us. I've been within the industry for about 15 to 20 years. And I've seen and been done design, UX design, service design for 5-10 years, computer sciences for 15-20 years, and the intersection where you're actually in nowadays matching the possibilities of technology, especially deep learning and machine learning, can bring into the table to human behavioral. That's where all the value is happening. That's where all the breakthroughs happen, but it is extremely hard. You have to do something that is desirable, and that you typically reach by the method of user experience design, user research, knowing holistically the situation where you are. You have the technology part, you have to be very on top of where the world of technology is going, and you have to create the profit and the business and be viable on that. It's a short area where you actually can create a good value, and it matches a lot of different competencies and a lot of different experiences. We're going to share some of that today, sharing some of the stuff of what we do first, and then coming to actual one of the methodologies that we use to get that thing solved. That sounds good?
Yes.
Cool. Everybody still comfortable? If you really get like panicked, just raise your hand.
Yeah, if you get lost, raise your hand.
Yeah. Cool.
Hey. Yes, I'm Kyle. I'm a machine learning engineer. I'm also the tech lead for the AI group here at Digitalist. I just want to gauge the audience. Is there any people doing machine learning or AI, like coders? Okay, we've got a few. Oh, good stuff. Yeah. How about design?
Awesome. Good.
All right. Any like tech leads themselves, like management type. Oh, forget all
Cool.
that. All right,
Yeah.
cool. Yeah, so our AI team. So me myself, I specialize in computer vision, so convolutional neural networks. I do like semantic segmentation. I've worked in facial recognition and surveillance and all that, and some image generation as well. We have experts in natural language processing, predictive modeling, as well as data science. But the good thing, and what drew me to Digitalist about 1.5 years ago, was that we have support from full stack engineers in UI, UX, so that our technology gets delivered to users in a meaningful way, and that's really valuable to me. So this is our tech stack that everybody pretty much used a lot of these things. We prefer to code in Python. We use TensorFlow. Sometimes use the Keras interface, it's a little easier. But we do all our prototyping in Jupyter notebooks, whether it's in Google Colab or locally on our machine. We do a lot of cloud training. So right now we're using AWS. I'm actually using Valohai as the front end. You know, from Valohai we'll be speaking later. It basically like orchestrates our training jobs. It enables us to catalog our experiments. So we're working like, I work up in Vancouver, and my colleague Mikal, he works down here, and we're just able to like run experiments and catalog them all and go and reproduce those results as we go along. So some of our current projects. So this is so depth from stereo. Okay, so there's a lot of applications in this. One of them being self-driving cars. You put a stereo camera on the front of the hood, you should be able to infer some depth. This is a typical network that we've been experimenting with. Has anybody heard of like the UNet? If you've ever done any Kaggle competitions? Essentially, it's this encoder-decoder network, the first part, right? So, but then we take the loss from the right image and the left image. If you have any questions about this, we could talk about it afterwards. But essentially, this is our network learning to depth. You got that?
Yeah, I got that.
So these are just the kernels of the first convolutional layer. So they're learning how to best extract information from the source image to be able to infer the depth. So the loss is being calculated against the depth map. As you can see, eventually, these kernels, they're all random. They start to take some kind of shape, and then this is the result that you get. You end up getting a nice smooth depth map output. Plenty of applications on that. So if we take a look at one of the kernels, just to further explain, I know not everybody is doing ML stuff. Oh, sorry, my bad.
No worries.
You just go to the next.
Yep. There we go.
So like there's that one satellite image, I was able to get the depth from it. So let's just take one kernel. So there's like hundreds and thousands of these. This is just one kernel. So if you convolve it across the image, just one of these kernels, it decided that these upward sloping lines were of importance to it. And it does that 64 times across many, many layers. So there's tons of these kernels doing their work to extract information from the image to be able to infer depth in the image. We're not going to talk technical about that stuff. We're actually here, I'm going to be drawing from my experiences from applying the rapid prototyping and design sprint approach to AI. I'm going to get some context on it shortly. So there are a lot of technical challenges for machine learning in production. I mean, if you have, when you're dealing with satellite imagery or medical imagery, it's typically at a high resolution. We all know that like deep learning, you need lots of imagery, you need lots of data in your training set for it to learn something meaningful. Moving that data around, storing it locally, just doesn't work anymore. When you're hundreds of gigabytes, maybe even a terabyte for your training set, it's just not feasible. And when you're working at multiple locations, you want everybody to point to that same training set. So that needs to typically live in the cloud. So data management's a big part. And then also, when you're trying to satisfy customer demand, you can't just be training for weeks on end, right? Like you need to have a way to speed up that process. And one of the ways, in terms of distributed training, is to maybe replicate that same model across, let's say, 16 machines. And you take your data set, split it into 16 parts, train 16 separate models, but then when you do that gradient update, it's a combination of all the gradient updates. We can also go more into that. Please talk to me afterwards about that stuff. Again, it's not meant to be technical, There's also deploying and scaling those models as user demand rises. We've also run into problems with model versioning. So you train a model on a certain amount of data. You actually need to version that data, you need to version that model, because you're not going to be able to replicate those same results unless you do so, unless they match up. And then everybody's probably seen poor model performance on production data. So you did all you could. Your validation is perfect, 95% accuracy. You deploy it to production, and your customers aren't happy. You're getting poor performance on that. So you need to be able to take that user feedback, fold that data into your data set, and retrain your model to perform better. And so that retraining pipeline really needs to be solid. You need to be able to react to these things happening and improve your model to satisfy their needs. But again, we're not here to talk about technical stuff. So being a tech lead, you're not always just responsible for code. I love to code, but you're also responsible for your team's professional development, bringing in new work. You kind of have to have a little bit of business development background. I mean, I've been doing that lately, and that's kind of what this is all about. So brings up the point, how are you going to work on all these challenging and rewarding problems if you don't have any work? You don't have a project to work on, how are you supposed to get to production with no product, right? And so we need to secure contracts in order to work on these problems. And so since I started trying to get us more work in different areas, here 1 and 2, I'm totally well versed in that. So the first one is a tech company looking to make AI into their product. So let's say they have an AI with facial recognition, that's the product. Number 2, a tech company, they have a great product already. Let's just use Spotify, like an excellent music streaming service. They have pretty good recommendations as well, but maybe they don't have enough bandwidth or the talent on site to maybe further progress their models or add even maybe like a chat bot or something. And so we're not here to talk about those ones. It's the third one here. So this is non-technical companies. So I'm talking like energy companies, maybe government organizations, and so forth, maybe banking or financial.
Real life companies.
Real life companies, yeah. And so they're not actually looking, they don't care that there's AI, but they would like to use AI to increase their profit. They want to use it as a tool. Okay? They want to give them some insight maybe in decision making, to be able to forecast the future so they can budget properly. And so the problem with those encounters is I found that they know that AI can help them in machine learning, and they've seen maybe their competitors, like LinkedIn articles or in the news using AI as like an AI initiative, and they have maybe benefited from it, but they're just unclear on how it can benefit them. And our problem is that we have all the technical competencies, and we know that we can help them if we get our hands on their data sets. But we found that simply offering our services, maybe showing past products, it wasn't convincing enough for them, and they were pretty resistant to taking on these projects, even though we know that there's a lot of work to be done there. And so after many trial and error kind of situations, we have designers at Digitalist, we're probably like 50% designers, 50% tech. They've been doing this design sprint approach for many years with a lot of success, and we decided to go down that avenue. And I'll let Teppo address what this design sprint's all about.
How many of you have been part of a design sprint? 5, 10? Cool. How many of you have been driven a design sprint? Being a coach? Cool. Okay. All right. Good. Hey, the definition for the ones, it's originally a methodology developed by Google. There's a couple of very good books on that one if you want to learn yourself. It's full of set of material to actually coach yourself. It's a condensed, pretty much originally 5-day design sprint approach of pushing things on a time constraint, 5-phase process, a lot of design thinking on it, but very much focus on getting things done on that 5 days. We've had within the whole, whether we've done online services, new products, even physical products, we've had very good experiences on being able to shrink product development pipelines, especially in the early stages of product planning, from 6 months or 4 months into actual 2 weeks, 3 weeks. You need your preparation in the beginning, whether it's an AI-related design sprint or not. But 3 weeks is still a significant change compared to the fact that you're trying to figure out what to do, where to focus, how to push forward. And that's what the design sprint is all about. Within the customer experience lean lab, the lean approach, the way how we try to push things forward with our client is on this world where you could spend 8 months of developing your neural network and get a 3%, 5%, 6% increase on the effectiveness. On the business strategy point of view, you want to show immediate results. You want to know you're going in the right direction. And you want to try to be as concrete as possible. Even though the puzzle that you're solving is actually reasonably cumbersome. It's actually very hard to understand. You typically don't find a single person in the project that could capture it all. But you need a team effort, you might need 5 to 10 people, and you still want to go first. And very lean things going forward. So we work on this, that we first of all split the whole thing. We have a business and service strategy team, stream, and a team that drives that forward. And with the help of different sprints, we create the type of artifacts, the type of approaches, real-life scenarios, prototypes that we can then push into service validation or to actual development. And that's where we're using this tool. We find it extremely useful. Let's go deeper. Let's actually look at this on a more holistic time frame. We're actually getting this early stage a lot more quicker. I've been part of some of the product development companies that and doing roadmap development for 2 years ahead, pondering on that yellow stage for even years to define. And currently, we're actually getting further down the road quicker in about 3-week sets. That's a big promise, but that's real life as well. When you pack the right skills, the right methodologies on the same table, you're able to reach things a lot more fast. Let's look at it concretely, because we actually like concrete stuff.
Yeah, so what was the Wikipedia definition first?
Yeah, that's first.
Oh yeah, okay, so this is the Wikipedia definition, and after that, and all the help from the Digitalist design experts, I came up with my own definition. It's the same thing. But the guys, he's wearing a TensorFlow shirt now, and they are talking about a neural network on the whiteboard. So it's taking an AI design sprint, it's time-constrained 5-phase process to bring a new AI product, service, or feature to the market. And so the main goal of this AI design sprint, it's a pretty nice goal to shoot for, is to provide a proof of concept, end-to-end solution. So right from data consumption to training to deploying that model and then querying that model for results to solve a specific business case. And it's trained with real company data. So the company that you're approaching, you actually get samples of their data to do this. And so the key benefits of this is it actually is appealing to these non-tech companies. It's like a low risk, like we call it like a test drive of AI. You're able to actually see, are we fit for this? And how far away are we from being able to do this, right? And so, and it focuses on solutions that provide the company most value, because they're just really looking to turn more of a profit. They don't really care how cool your technology is, they just want it to work. And so, in doing so, creating an end-to-end solution, one of the main things that's come out of this is that we identify gaps in their data pipeline. Sometimes they don't even own their data. Sometimes it's like in a third party, and they have to email somebody and get a spreadsheet sent to them, or like a CSV file. And that's not cool. That's not going to work for us. And then so after this is done, this 5-day sprint, a lot easier to scope that project. If we are to go forward with that customer, it's a lot easier to scope that project. And also throughout that process, we're able to manage their expectations. Because kind of as we know right now, AI has got to be at the peak of its hype. They're like, it can solve the world's problems, right? Not necessarily the case in production. And Google isn't helping with all their demos, right? So here's our 4-day sprint approach. So the first day, I missed a day. So this is the initial exploratory data analysis. when I get emailed 100 Excel spreadsheets and I have to parse through them and visualize them both.
The ones that you
The
have
customers
driven,
don't see that.
the ones that you have driven, like the so-called original sprint approach, from the first day you actually focus a lot on the user research, behavioral parts of the thing. You've done a lot of user interviews, hopefully in before entering the sprints. This just takes another. You're actually looked at deeply on the data.
Right. Yeah. So I look into the data. What I'm trying to do is just to make sense of it myself and be able to provide a couple good visuals for this day one when we're. So I'll go through the days. But you really want to have something to show to get the discussion going. Because a lot of people, they just haven't even seen their data before on a simple XY axis. They've never seen it before. So in day one, we unpack and decide, because essentially we're just like laying the groundwork for what's about to come for the week. But we also, in doing so, we map out some ideas, and since we have everybody in the room, Devo might have mentioned, like, in the workshop, you need some decision makers. You need maybe the CEO, maybe someone from maybe 3 different people from 3 different departments to give us different perspectives. So you have everybody you need to actually make decisions. And so here, we can actually decide concretely, what are we going after here? You know, if we're going to take on an 8-month AI machine learning project to increase our revenue, it better be a good decision. And we have everybody in there, so there's no excuse. And so day 2, we further explore this idea by forcing them to fill out a business model canvas. So they actually have to say, now we have an idea, it's supposed to be great, how's it supposed to make money? Where's our revenue stream, right? Who's our target customer or user base for this? And then and I'm also missing between day 1, day 2, and day 3 overnight. I'm back at the hotel room coding up the solution because it needs to happen. So between day 2 is when we actually have a concrete target to go after. And then overnight between day 2 and 3, we prototype it, and so that prototype is actually it's validated with real users that they filled out in their business model canvas, who they assumed would benefit by using this. Okay, and then by day 4, we can iterate maybe one more time after that user feedback, and then we're able to really truly validate if this is a good target to go after in the long term, and then we can actually provide them with a real more concrete plan moving forward. Maybe we need to start getting data and moving it here and having it stored this way. And maybe we need to have a different company culture in order to adopt this stuff. Because some people are resistant. Like maybe guys working out in the field at an energy company, they don't want to pull out their phone and look at an app. Like maybe it just doesn't work that way. So this is just some visuals. Also, this is the team that will show up. It's 4 of us. We have somebody in business development, a design expert, machine learning, as well as a software architect, so like a full stack guy. Question?
Yeah, sorry for interruption, but what I'm trying to say is your prototype is like a mock-up of the solution with the assets that you imagine that the client.
Yeah. So yeah, I'll actually.
Tell you more about that.
Totally. Yeah, you bet. So in doing so, since we have all these decision makers in the room, when we decide on something, that's when we say, like, we need that data, and they'll do what they can to give us that sample right away. And you'll see, I'm actually going to go over a real use case at the end of where we've done that. Yeah. Does that answer your question?
Yeah.
Okay. So one of the crucial parts on day 1 is that you need to educate everybody. Not everybody knows about AI and machine learning, and their view of AI might actually be distorted. There's like killer robots in Will Smith.
Media has a lot of bad things on the AI at the moment.
Exactly, like spying on them and stuff, they might be afraid of it. So we give them some nice concrete examples of what we mean by AI. We really mean machine learning, applied machine learning, maybe data science techniques. So you educate them on that. And then once you educate them on the capabilities and limitations of machine learning, they can come up with their own ideas. Now they're actually able to identify and come up with a plan that you yourself wouldn't have been able to think of, even given their data. They have insight. They're in their own industry. You don't know their industry. They know their industry. And so they map out where they think that AI and machine learning can help their business in different areas. And then after that, they vote and they narrow it down to 1 or 2, and then we act on that for day 2. So day 2, like I said, we forced them to fill out one of these. I was with them, and it's actually really, really hard. You think your idea is good, and you get to this part.
How many of you use business
revenue
model?
stream.
Business model canvas. Oh,
Yeah.
good. Good, good.
So yeah, so you know how difficult of an activity this can be, or how disheartening it can be to see your idea just be like totally wrong.
Wrong.
Yeah, so that's a really good exercise, and we're able to move forward after that. And then we bring in the assumed user base of this, and we have them validated. So then by day 4, we can present our results. Everybody loved the results. Everybody loved to see their own data in action. It was really neat, and their own ideas come to life in just 1 week, right? And so here's a real customer problem. So after day 1, I showed them, so they were having issues with hiring and firing. So it's a seasonal process like with this type of construction work in the energy sector, where they have to hire contractors for the spring and lay them off during the winter. And timing that has been variable, or so they thought. And they would really like some forecasts as to how much workload they're going to have going into the spring and coming out into the winter. And so the data I was provided with 3 years of work tickets logged in Excel spreadsheets. Fun.
That's a dream job. That's what everybody was thinking. Hey! Awesome.
Yeah, that was fun. So there was the date received, when it was completed. So maybe you could see if it was like late or not. Also the city that it was completed in, and the name of the contractor who did the job. So maybe you can say, this guy has a lot of late tickets. But I didn't do that because I didn't want to put anybody on the spot. So after parsing it out, I gave them a view that they'd never seen before. Believe it or not, this is their work tickets logged over 3 years. Does it look? It looks pretty like the same things happening over and over again. Yeah. Right, but maybe not exactly. But you could say that this is a seasonal pattern, right? It's cyclical. It happens every year. The same. It goes up and it goes down. And so I decided to plot that against the weather or max temperature. And so you can see, and not to be confused, like you don't want to just assume that they're correlated together because they both could just follow the same seasonal pattern, right? So weather might not mean this. But you can actually maybe say like the change in temperature. So as this as a change upwards, maybe we get a spike because you have high temperature here and lower tickets here. So it's really not so straightforward. But again, they lost their mind when they saw this because they've never seen that. And so here's the machine learning part. So what they really wanted, so the user, he said, if you can put me in the beginning of spring and tell me exactly when the spike's gonna come and how many people to hire, like I'm in, like that's 100%, right? So we did some back testing. So we went back, pretended like we're in March 2018. So the blue color here is what we use for training data. And then we held out this orange stuff on the right to simulate what might have actually happened. And so we see ourselves here at this situation. If you have like a 3-month view, like you can't really predict this. I mean, like it's went down, went up. It's kind of like looks flatline. And so this is what, so I trained, if anybody wants to know the technical details, I did an XGBoost regressor, let's see, random forest regressor, linear regressor, and elastic net. So I just pretty much just sklearned everything and did an ensemble and averaged the results. And so this is what, just using the ticket volumes, no other features. And sure enough, it has a spike, right? Just that insight to know that it's going to increase will probably help them, right? And I'll probably smooth out the curve so it looks pretty, but so this is the actual. So it did indeed go up just using historical data. I mean, like that's like maybe someone could have looked back and said every April 1st it's a lot. So, but anyhow, this provided value to them, and like I wouldn't have thought of this case had they not given me the data. Yeah. And so you see we undershot here and then overshot there. But you average those out and it's okay. And so if we plot that to temperature, we'd probably add temperature as a feature to our data set moving forward. If we want to move forward, there was a really interesting insight somebody said. They said, if we go back to the first one, somebody said, oh, how come there wasn't as big of a spike in 2018? Someone said, oh, because there was an election that year and they didn't have as many projects. Just like, wow, I wouldn't have thought of that either, right? Like you need to show this stuff to them and it'll really help you out, especially if you're trying to engineer features to make a better model. Having them completely involved in this process, it's huge. And so the key takeaways from AI design sprints and AI in production for this type of user or customer is that industry knowledge is invaluable for that like election example. So that helps you with your feature engineering when you actually want to move forward with this project. And then again, less is more. So like simple data visualization is huge. And simple models and maybe even rules-based alerts. If month equals April, higher, right? And that's it.
All right. Thank you, Kyle. Thank you for the first. Any immediate questions? Let's have a good 10 minutes break. We'll continue about 20 past. I'll give you a warning sign about 2 minutes before or so on. Feel free to grab a drink, some snacks and all of that. We'll switch a little bit the presentation and all, and then we're good to go.
Is there any questions? I guess we can.
Yeah, we can.
Yeah, question. Of course, yeah. So I don't know if you saw user type too. So someone with an existing infrastructure and software, you need to just but the AI design is usually to scope out and investigate in a low risk kind of way. It's like trying to prove the concept. Okay. Yeah. But if you have any suggestions as to how that could be used, like in a sprint fashion throughout the project, I'm open to that. Yeah.
Sprints can have any point in the project.
Very good point. Totally. Yeah, that's because I'm not so well versed in design sprints yet. Yeah. Cool, thank you.
Cool.
For the dev are you using RGB?
Yeah, we use RGB images as well as HSV and some other color spaces like YCRCB. Yeah, we're playing around with that. Oh, yeah.
Just for fun, did you find your sensing on force perspective images?
What is that?
Like, have you seen The Lord of the Rings?
Yes, I have. Yeah.
So they use like sets which can have force perspective, like one character is in the front and one character is in the back. And
Like blurred.
It looks like
It's blurred?
yeah, Gandalf is 6 foot and the Hobbits are 3 feet.
I bet it would fail on that for sure.
It would be fun to see.
It would be fun to see what it predicts. Yeah, definitely. Yeah, good question. Yeah.
Toi legaattoja vaihtaa koneet. Ja nyt se näyttää toimivan.
Noin striimiklaat siinä alussa.
Sait sen löytyä?
Kolmannen kestämisen jälkeen uudestaan. Ei mihinkään koskaan. Yeah, we've actually worked with Meetup and it's not
I'm just gonna talk briefly about
all right, 1 minute. Dear friends, 1 minute. How do we get all these people away from the action area back into the yeah, that's cool. It's plural. All right, everybody. Internet doesn't wait, so take your seats. Yeah. Sorry, you got the whistler. Hey, this is awesome. This is what we call co-creation. Now the internet starts. Thank you. Perfect. Hey, good. I'm actually glad that all of that discussion, questions, and enthusiasm is in the place. That's, of course, a big thing of the whole evening. You are the one who is making it. We're just giving the premises and some of the food for thought, so to say, and a little bit for the mouth as well. Our next speaker, Eero Laaksonen from Valohai, opens up a little bit of how does it go in terms of very performance-related issues when you go deep down in a production with your machine learning model. We've seen we want to open up the both ends, also the way to how to define the services, how to work with customers, how do we do it, and then the so-called kind of deeper, heavier, the real life. How does it look from the person that is working with the model itself? And that's why having Eero here today. He's also a great chap and a good guy to ask questions on how things really are when the machine learning works. So welcome. Give a big hand.
Thanks, Stefan. Can everybody hear me all right on the back? Is this volume okay? Great. So I'm going to be talking about scaling deep learning or maybe even machine learning operations. There's nothing super specific about deep learning in this talk. This is of course a huge subject. Anybody who's been working with machine learning at scale will know that there are so many things. Right, Savi?
Yeah.
But I'm going to be concentrating today on one particular thing that I think everybody should get their heads around. So, like Teppo already said, I'm Eero from Valohai. I'm the CEO and running our business here in San Francisco. That's it for me. I'd like to hear a little bit about you guys. So, how many of you are some sort of software developers? Okay, yeah, that's a good bunch. How about data scientists who identify as data scientists? Okay, okay. How many of you have written some sort of machine learning code? Okay, okay, we have a good bunch. Then how about deep learning code, something that they consider to be deep learning? Okay, so that's a nice amount. And then lastly, how many of you have had some sort of machine learning thing model in production? All right, we still have some hands. Nice, nice. They keep dropping all the time, but okay. So I'm going to start off with a Google research from 2015. How many of you have seen this picture? Not anyone? No one. Okay, a few one. Oh, well, you have. So what Google did in 2015, they started looking into their in-production machine learning systems, and what they found out was that people working with machine learning only spent a really small amount of time. You probably can't see it, but this black box here is the machine learning code. And most of the time goes into something completely different. This, if it's not obvious, is a big problem. It's a big problem because the people who are able to build models, who are data scientists and so on, are very scarce at the moment. It's hard to find talent. These people are expensive, so it doesn't really make sense that they're spending their time on something that's not very relevant to driving the return on investment that data science or machine learning is supposed to be bringing. And to that matter, what we are doing at Valohai is we're trying to make it look a little bit more like this. So these guys who are actually good at machine learning should be concentrating on machine learning. So actually, like, did you see this comic? So today I see so many companies living like this. Like, somebody leaves the company who's been working on machine learning, and all they leave behind is a huge mess of files. Well, we've been working with software development and figuring out a lot of stuff. Like, if we look at 20 years backwards, we had a sort of similar thing in software development where people were deploying like 4 times a year, maybe on CEDs. How many of you have developed on something other than internet? Have deployed code on something other than internet? Yeah, now one person. Yeah, that's right. But 20 years back, we would like deploy maybe 4 times a year, and everything would break every time. But something happened in between. So the world looked a lot like that. But something happened in between. There was version control, there's continuous integration, microservices, and people could argue that there's a lot more that happened in between in 20 years. And now today we have companies like Netflix, for instance. You guys are deploying, I don't know how many times a day you're deploying code.
I don't think anybody's
nobody cares anymore because it doesn't break anything. It's just everything works and you're able to do it. But still, machine learning looks like a huge pile of mess. And what I'm going to be focusing on today is why is software development so different from machine learning? And what's at least one of the key differences? So software development is different from machine learning, and everything starts from it being more of a data pipeline. So when you start working with machine learning, you usually have some sort of data. You always have some sort of data, and then you have some sort of code, like my first data scribbles.py, that does some level of data extraction or data transformation or whatever, and that comes up with another set of data that is then maybe used by a training script that then comes up with a model. So we already see that if we're using traditional software development methods, we're probably storing the code in version control. Hopefully everybody is storing it in version control at least. I know that everybody isn't when we go to Jupyter notebooks and stuff like that. We see a lot of this, but anyways, you should be. But then we see that there's a lot of other stuff. Maybe even these can be in different repositories, so you don't really know that for any version of commits of training code, what was the previous version of code that we used for doing the data transformation, and what was the data version that actually went through this pipeline to come up with this particular model. So I'm going to argue that machine learning is fundamentally different from software development due to data entanglement. So your code and data are actually affecting the behavior. In standard software development, your behavior is only affected by code, but when we go to machine learning, your behavior always comes from a combination of data and code. So data and code should be treated equally importantly. So if we already have these tools for software development and we know what to store, then what more do we need to add? Here is, I think, a pretty good list of things that should be stored and tracked and kept on record for you to actually be able to understand your whole pipeline and what's happening and reproduce it and maybe have new people joining in your team and actually understand what other people have been doing for the past 6 months. On the input side, you should probably be versioning your training code. Most of the people are today doing that. Then you should somehow be able to version your parameters. You should know what parameters you use to come up with a particular model. Today, there really isn't a standard way for doing this. You just have a script and then you run it with, let's say you're doing hyperparameter optimization. You just have a script and you run it with a combination of 1,000 different parameters. How do you know what model came up from what version of models? Many people, what version of parameters? Many people have built something on this, but there's really no standard way for tracking this. Then what was the data set that you used? So you should be able to go back into that particular version of data, and especially when we get into more regulated areas of business like medical or self-driving and so on. There's a lot of legislation that already is in place to be for you to like detect bias and be able to show what kind of bias might have been generated by the version of data that you generated. And if somebody is going to be coming to your door and asking like, how did you come up with this prediction? What was the data set? Is it skewed in this kind of way? If you can't even show what was the training data that you used, it's going to be a big problem in the future. Then used hardware. This is more from operative perspective. If you're training with a large team and coming up with models all the time and working with different sets of data, it's pretty good to know what kind of a hardware was used for what particular training, especially if you're going into really large models or really large data sets and actually training in parallel, for instance, so doing data parallelism. You might have a cluster of 100 computers that all have 16 GPUs. So it might be pretty good that somebody can replicate that without having to spend 6 weeks configuring that same cluster. You should be able to replicate that exact same cluster for that training if you want to do it on a new data set. So that's really important. Less important if you're doing something really small that can be run on any kind of hardware. Then the environment, like package control, is really complicated. Getting more and more complicated. There's new versions of everything coming up all the time. But if you're gonna have any kind of transferability of work, then you're gonna have to have some level of tracking of environments, how to actually execute the code that you've written. Docker and containers are really good for this. Some people are using Conda and stuff like that, but I think Docker is going to be the winner. I think most people think that Docker is going to be the winner. And then one of the things that I don't think I've seen almost anybody do. Are you guys tracking experiment cost? Yeah. Some of the really advanced players are doing this. But once you really get there and you have a large team of data scientists working on large experiments, you're gonna have to start gaining insight into how much your training is costing you. And not just getting that clump of how much cloud compute we used on GPUs in the last 6 months. That's not gonna tell you what's the like division between projects. Like let's say this project is going very well, but they're not using almost any money, so they're probably more a better project to bet on than these guys who spent like $500,000 on GPU compute and haven't provided out anything. So from management perspective and from like just driving your own work, it's really good that you have transparency on how much money you're spending. And it's using standard cloud today, it's almost impossible without adding a lot of extra layers to that. Then on the output side, you're gonna want to save the model, obviously. That's end result. You're gonna want to deploy at some point, so probably should have it somewhere. Then the logs for debugging purposes and whatever reason you might need. Everybody's gonna need logs at some point, so you should probably save them somehow. And then the actual results. And with results, I mean like snapshots for TensorBoard and stuff like that, so you actually have a good understanding of what happened. And yeah, and statistics on top of that. How many of you think that there's something missing? I'm always happy to hear if somebody has like, yeah, I think you should be also tracking that, and we're tracking that, and it's not on the list. No, it's completely exhaustive. And does everybody feel like they're already tracking all of this? And everything is okay? Yeah. Yeah.
One pipeline, or it's a different pipeline for the data sets and for the code? Only
yeah. So I think this should you should be able to understand this throughout the pipeline. So if you have multiple steps, then you're gonna have to have understanding of like each single step needs to have an understanding. I use this data that was generated by this run previously, and then that run will have all of this information too. So that's how the pipelining comes into play, because every part of the pipeline is essentially just taking in data and then putting out data and doing stuff in between, some sort of data transformation. So if you're using a set of data in any point of that pipeline, if you're tracking everything, you're gonna know the previous step also. So that's how pipelining comes into it.
You considering man-hours in the experiment cost?
That's a great question. If you ask our platform and what we're doing, no, we're not currently tracking man-hours, but I think that I've heard at least. Are you guys doing no? No, yeah. No, just currently at least we're just tracking the compute cost for it. But that's a good question. Yeah. So essentially, I think today most companies are more focused on maybe checking the training code and models, but there's a vast area of stuff that should be tracked and should be checked for you to actually be able to replicate and do like really robust machine learning. I'm gonna quickly do a plug and show how we've solved some of these issues. Mostly just like give a concrete example of how this might look like in real world. So let's see. So my internet's working? Yes, it is. So on Valohai, if you create an execution, we're gonna can you see in the back? Probably not, so I'm gonna zoom a little bit. So when you create an execution, you're gonna select the step for your pipeline. There is the hardware that you're using. There's the version of code that you're using, and there's the environment as a Docker image. We're storing the environment as a Docker image. Then the command how to run it, the input data that's coming in, and then parameters that you're running it with. And when you create the execution, everything is automatically stored, and you're able to go back to that experiment and see all of that information. And if you're using the platform, like everything just becomes completely repeatable and tracked automatically. So I think that world is going to be going more towards these kinds of standard approaches, and that's what we see, like companies like Netflix. I think we're going to hear something about your internal tooling that's doing something similar. Uber has a similar tool. Airbnb has a similar tool. Facebook has a similar tool. Google has a similar tool. So definitely the world is going into this direction. What kind of approach you want to take yourself, that I leave up to you. But this is the stuff that you should be doing probably if you want to do this in production and on large scale. That's it for me.
Thank you very much. Any questions? Challenges? Challenging questions? Compliments? No? Oh, hey, we got one. Good.
I have a question.
Yep.
I'm sort of a new data scientist, and I'm wondering about doing prep. So when you're going to production, like how do you handle cleaning data in production?
Yeah, so cleaning data is obviously a huge thing. I think it depends a lot on your data, on the type of data that you work with. We are mostly deep learning focused, so we don't do machine learning ourselves. We just do the infrastructure and help companies execute faster. But what we see our companies doing mostly, it's images, and like most of our customers are using images, and the way they do cleaning data or fixing their data or doing feature extraction is just like large batches. They have their raw data set, let's say on S3 if they're working on the cloud. Raw data on S3, then what part of the pipeline is a script that does some sort of image transformation. That can usually be done pretty fast on CPU, and it's not like you can do it. So they use smaller machines for that. That's easily parallelizable because it's just files that go through the same thing. So you can split it on different machines if you have large data sets. And then the output is just stored on S3 and versioned, and then that is used for training. But then if we go more into structured data, like databases and stuff like that, there's like a Spark is a good way to go at it. Spark is I think very good for what do you guys use?
More or less everything under the sun.
Yeah.
So you don't dictate any of the choices that our data scientists have to make. So Spark, Hive, Presto, those are most of the big data mining tools that are willing to do.
Cool. Good.
Anything
Aaron
else?
Anything else? Aaron will be around the whole evening.
Yeah. And we have t-shirts on the tables on the back if you want this kind of a t-shirt.
That's handsome. Everybody who looks handsome carries one of them.
And if one of the sizes goes out, then I have more somewhere, so come on.
Awesome. Awesome. Good. Thank you, Aaron.
Thank you.
And welcome on stage, Savin from Netflix. I've always wanted to, like, in today's world, when things on starting up from user research, starting up doing your service design and design thinking on the actual product development phase, in Digitalist, we've always wanted to encourage people to share a lot of experiences between each others, even though the ones that are working on a design expertise or a machine learning expertise, and I'm glad to have someone here from Netflix sharing an example of how they do life cycle plans. Stage is yours.
Thank you. So, am I audible? Okay, all right. So, my name is Savan, and I'm an engineer on the machine learning infrastructure team at Netflix. And today I'm going to talk about how our data scientists work on an ML problem. So, most of the problems that they encounter have already been covered by Eero. So, this presentation might be a little bit shorter than I originally intended. I have a video. Let me see if we have any audio. Can you hear this? Okay, all right. So I guess we are very well known for our recommendations, and I hope most of you here are Netflix subscribers. So I would not go deep into how we do recommendations or so. Let me instead focus on what our business model looks like. So this year we are projected to spend upwards of $1 billion on marketing, which makes us sort of like one of the biggest brand advertisers in the world. We are also going to spend roughly $8 to $9 billion on content buying and producing our own shows, which also makes us the biggest content producer in the world. Now, this is sort of like the positive reinforcement loop that we are in. We spend all of this money marketing our content, buying new content, so that we can program it on our service and then make it discoverable to our users. Then happy users come to us, they pay a monthly subscription fee, which we then funnel back into marketing and content. So it's really important for us if we have to be successful in this business to keep our users happy, because if our users are not happy, then the money will dry up, then we will not be able to program the content that they want, and eventually this thing will become too difficult to support. So we take the help of machine learning to essentially inform us on a variety of different facets. So we apply machine learning in computational advertising to figure out what ad to show to which user to sort of promote our original content so that they'll get excited to sign up and watch. We use machine learning while figuring out what to program on our service, making decisions as to what would be the predicted demand for a particular script, and that will inform the amount of money that we are willing to pay to have it on our service. You must be very well familiar with Netflix recommendations. The algorithm that backs it, we call it PVR, Personalized Video Recommendation. That's the algorithm that is responsible for assembling the front page every single time you visit netflix.com. We also run our own content distribution network. This is something that not a lot of people know about. So people know that a majority of our infrastructure is on Amazon, but that interaction only happens when you are on netflix.com. As soon as you click play, all the video streaming, that's taken care of by our own content distribution network, and you can think of that as sort of like local caches that we have placed at your neighborhood ISP. So it becomes incredibly important for us to gauge what pieces of content might become incredibly popular in a particular geography, so that then we can seed our boxes so you don't run into rebuffer loops, and we can sort of like surface very high definition content with the lowest cost possible. And that leads us to happy users, and we can figure out what is the lifetime value of a user, and we can program to their tastes. So now that I've spoken to you about like the importance of machine learning at Netflix, the next obvious thing that to look at is what does a development process look like? And for a lot of this, Eero focused on in his previous presentation. So there are two different facets to look at this. So one is the technical point of view. If you are working on a machine learning project, you would be responsible for figuring out where the data is. You'll clean the data, you'll probably do some feature engineering, you'll do model training, you'll deploy your model, and you'll do some validation and tests on it. And then perhaps you'll talk to your neighborhood engineer and figure out ways to put that in production. There are a variety of tools out there with very rich ecosystem that helps you achieve each of these steps, like TensorFlow, PyTorch, a whole bunch of libraries and ecosystem around that. But then there's another facet to it which is very often neglected, and like Valohai, for example, is doing incredibly good work in that area, and a lot of other big technical companies have also figured out that this is indeed one area that needs a lot of focus on. So from a developer point of view, you write some code, you would potentially want to share that code with a peer to do some reviews, get some feedback around it, or perhaps just upload it to somebody else to work upon. And once you have figured out that, okay, this particular model works on this limited set of data, you might want to now scale it out to like the entire data set, which might not entirely be possible on your laptop. And once you have figured out all the scaling challenges, once you're training on all of these models, then you want to push these into production. And also, once you have developed a model for the very first time, that's not where your job ends, right? You need to make sure that your retraining pipeline is properly orchestrated. And once you have those models, they get into production in a very seamless manner. So this is sort of like the funnel of applied machine learning as it looks like today in most of the organizations. You start with a whole bunch of ideas. You try to prototype on them. And very soon, when you want to move to production, there's sort of like this disconnect. You have to lean into engineering teams if you are investigative, let's say distributed training. If you are training anything like 4K videos, trying to translate them from like 2D to 3D, it needs significant engineering support, and many times data scientists themselves are not really well skilled to take on those challenges. Also, you might come across certain ideas that you might want to take upon in the future, so you might just want to park them and then somebody else might take a look at it in the future, or you might want to revisit that in a couple of weeks or months. And it gets really difficult to maintain and manage that context because once you move on to a different project, if you are not really well versed in documenting it well, you would have that lost context, and I don't really know if there's anybody out there who does really, really good documentation every single time. And so these are sort of like the problems that we run into more often than not. And the goal of my team is to sort of like provide these safe paths so that when you are moving from prototype to production, you are not tightly coupled to an engineering team. And if you're using the tools that my team is providing, it's a very, very seamless path to production without actually involving any engineers. As well as any single time when you have a prototype or an idea that you just want to keep on the site, we also provide this parking lot where you can sort of store these ideas and revisit in the future. And this sort of like enables collaboration and also makes sure that our engineering teams and our data scientist teams, they are highly decoupled as well as aligned so that they can iterate on their own velocity. So let me show you how we do that. So the product that we have built, we call it Metaflow. And the few key ideas that we tried to provide while building Metaflow was we wanted to keep it very lightweight, right? Data scientists have a particular skill set. They are very well versed in playing with data, playing with a bunch of different libraries that are out there, figuring out what an appropriate modeling strategy is. And we didn't want to layer on top of them a burden of using a library which sort of deviates from their normal day-to-day work. So it was really important for us to make sure that if we are building something, if we are providing a toolkit, it should not deviate them from their normal day-to-day work as they know. We also wanted to make sure that there's a seamless transition when they decide to move from development to production and perhaps back to development when they run into any issues. And we also strive to make sure that reproducibility is a first-class citizen. Most often than not, what ends up happening is you would work on a data science problem, you would run into a particular issue, you would perhaps want somebody else's eyes on it, and then voila, you are unable to reproduce the problem exactly. And this can happen due to a variety of different reasons, right? Your data might have changed, your library dependencies might have changed, your execution environment might have changed. Every single thing that Eero pointed out in his amazing slide, all of those things are variables, right? And any of those could change underneath you and you wouldn't even know. So we want to make sure that we are saving all of these artifacts, dependencies, data blobs, so that at any given point in time, people can resume from any workflow in the past. So let me give you a very small demo of how it works. So let's say this is sort of your model training process. You have a Spark SQL job that is executing a SQL statement, you're getting some data back, you're transforming them, and then you're fitting a random forest model on top of that, you're pickling that model, and you're storing it somewhere, right? So this is your fit model step. Looks very, very simple and straightforward. Now, when you bring Metaflow in, you are essentially now going from a linear flow that you had described very imperatively into a functional flow, which sort of now looks like a directed acyclic graph. So now you have instead of that one single flow, one single function, you have now two different functions. The first function is building your features. It's responsible for getting the data in and translating that data into features. And then the next step essentially just fits the model and saves it to the self.model variable. So as soon as you write this code and you try to execute this, we'll do a static analysis of this code segment, and we'll try to figure out what does your graph look like, what the data dependencies are, and what the library dependencies are within each step. And we would execute these steps in isolation on our compute environment. And also anything that is assigned to these self variables, we'll snapshot that for perpetuity in our data store, so that then you can come back and resume from whatever step you want to for whatever instance of the flow. So this is an example of like when you start executing the flow, it'll essentially get all the tasks, all the run logs onto your console, and these tasks could be running on your local box, or they could be actually farmed out on our compute cluster. But to our data scientists, it would just seem that they are just developing on their laptop or their hosted environment. We also provide some utilities. For example, usually what ends up happening is you'll have some sort of like a parameter grid that you want to sweep over, and we have spoken about machine learning flows as a DAG, right? So we provide abilities where people can specify a list of parameters, and then they can just iterate on top of that, and we'll take care of farming it out individually. Also, many times you might have one step that you might want to execute on a cluster of GPUs, or you might want to execute on some dedicated resources. Perhaps your laptop lacks sufficient memory, and you want to just farm it out on a cluster with, like, I don't know, terabytes of memory. So you can specify all of these as decorators if you're using Metaflow, and then we'll orchestrate the job as needed. Once you're happy with your flow, once you have figured out that, okay, it's running and it's providing business value, you can essentially take your flow and you can schedule it on our scheduling engine. So Meson is a toolkit that has been developed inside of Netflix. I'm not sure how many of you are familiar with like Airflow by Airbnb or Luigi by Spotify. So these are different scheduling engines, and Meson is a homegrown solution that Netflix has built that runs on Titus, which is our container orchestration system, very similar to Kubernetes. And so you can create your flow, and you can see that, okay, this is like sort of like a directly cyclic graph that was generated and is now scheduled on our orchestration system. And then this will just execute happily. Since we are also storing all of the dependencies, all the data artifacts that were produced in the mix, you can go to Jupyter and you can interact with your flow, see where your flow is at, what are all the different artifacts. And this really helps in debugging and diagnosing issues when you run into any trouble, as well as it promotes sharing of your code and idea sharing in general. The last part is, once you have built a model, right, somebody has to interact with the model. And that's where usually you would interact with an engineering team, and they'll take your model and they'll load that in their service. And a lot gets lost in translation because the vocabulary that data scientists use and the vocabulary that engineers use, it just doesn't align many times. And we require our data scientists to just write this very simple prediction service class, which has this method. They don't really have to know a lot about, how to host a service or what do API endpoints look like. We just take this function and all the associated dependencies on it, and we'll just host it inside a Dockerized environment. And then we expose these as REST endpoints so that the engineering teams, they are now just interacting with the model from this endpoint perspective. They are no longer concerned that, okay, what is the model at play? What is the modeling technique that is being used by the data scientist? How often is the model being refreshed? Every single time there's an update to this prediction service, we'll take care of doing a red-black deployment on behalf of our users. So in a nutshell, if people are using our tooling, our data scientists are now only responsible for their data science work. As they are familiar with doing, we have striven to provide as less overhead on their day-to-day way of work as possible. Our engineering teams, they are just responsible for deriving business value out of the data science work, and we are responsible for the infrastructure. So this sort of like separates all of these concerns very neatly, And our hope is that this will allow us to make everybody who is involved in an ML project be much more productive. So that was me. And we are hiring. If you are interested in any opportunities at Netflix, here's my email address. Hit me up on LinkedIn. And any questions?
The man who clearly had the coolest video of the evening, by the way.
Yes, please.
Sorry, I missed the beginning. So you have combined data sets. You have like traffic data, and then you have qualitative data about how people are using your service. Or like, do you use supervised learning or unsupervised learning?
So we have a lot of data sets and we have a lot of problems that we are working on. So saying that, okay, we use supervised learning or unsupervised learning would be premature because for different problems you would use different techniques. So it's not like... Yes. It depends on the problem space per se. There is no one single problem that we are working on.
Good. Any others?
Yes, please.
What about the backend for the API? Is it just something simple like Flask or?
Yeah, it's like Flask, forwarded by Unicorn. Yeah.
Cool.
How's the internal adoption been like for this tool?
So we are very new. So my team started like a year ago, and we have seen very good adoption. I think we are right now in the early majority phase, and most of our development has been guided by the needs of our data scientists. All of these things are not really things that we imagined and then we built out. It was more developed based on the interaction and communication with data scientists based on their needs and requirements. So the adoption has been amazing.
Is this going to be open source or is already open source?
It's not already open source. We are still figuring out if this is something worth open sourcing. So a lot of other companies have similar initiatives as well. So we are not alone in this space. Yeah. Yes, please.
You can clearly help a lot of functions in the company. I was wondering, do you actually go to, say, marketing or sales and tell that we could do this, or do they have the knowledge of what ML can do and they reach out to you?
So usually they have the knowledge in terms of what they can do. So we have a science and analytics team which has a variety of different functions. So one team might be focused on quality of streaming improvements, the other team will be focused on growth and marketing. So they'll always have ideas around what to build and what sort of modeling problems to look at. And usually they come to us for engineering assistance when they run into certain bottlenecks, and that's where we try to help. Yes, please.
What deep learning libraries do you prefer?
So in our architecture, we try to remain as agnostic as possible. So we haven't put in any sort of constraint that, hey, you can only be in TensorFlow world or PyTorch world. So we try to make sure that our data scientists have the freedom to choose whatever tooling that they are most comfortable with. So we don't want to make those decisions for them.
Yeah, it just seems like TensorFlow 2.0, like the eager execution stuff, like this class model type of architecture. It seems like that would be for that as eager execution. It seems like you use PyTorch for TensorFlow 2.0 because the graph you have to generate, like it's complicated. I've tried it before. All I'll say is like I'm impressed.
Cool. Yes.
Does your framework help to make sure that data in training is the same as the data at runtime?
So right now, for example, if you're doing any batch training or online training, if you are relying on the same library, then that's something that you get out of the box because your training code as well as your serving code is in the same repository or is relying on the same set of libraries. So from the code perspective, yes. From the data perspective, that's a problem that we are looking at in terms of like how to solve well. It's still a problem that I don't think anybody can claim to have solved 100%. It's always a work in progress, and I think we are in a similar state. Yes.
Go for
it.
it.
Please.
Also, when you have a model in production, can you monitor features and predictions and identify when it's no longer as...
Yes, exactly. So that's the thing that we are trying to provide here. If you are running on top of the tooling that we provide, then we can inject all of this telemetry and alert our users on the basis of that. So I didn't go into those specifics over here, but we allow users to track accuracy and all of the other metrics that they might be interested in. And at the same time, we also record and alert on like the response time and the behavior around that to diagnose any issues proactively.
Cool.
Yeah.
How do you evaluate the success of your tooling as you build it, right? So it's used by the internal teams. How are you measuring the success of tooling? Like, how do you establish that?
Sure. So Netflix has this culture of freedom and responsibility. So there is no diktat internally that all of the teams have to use Metaflow. So if you are a data scientist and if you think that my team provides you good support and the tooling makes sense, only then you would be incentivized to use it. Otherwise, you can just use whatever you want to use or like just be off the paved path. So we judge ourselves on the basis of number of happy customers, and that's what we live for.
I was about to comment on that one. How do you actually measure like the user feedback, both qualitatively and quantitatively? I mean, you having all that data, actually having all the data, how much people watch it and so on. I think that at least the quantitative part should be covered pretty well. Like, do you actually get the qualitative part as well?
So when you say customers, are you talking about customers who sign up for Netflix, or our customers are data scientists?
Customers who sign up for Netflix.
So I mean, I think we run like a variety of surveys.
Yes.
That's like a established way, but
Yep.
I don't actually work in that area, so I would be
Cool.
hard pressed to give you any specifics.
Yeah.
Yes, please.
You're automatically discovering like data inputs and stuff like that from the code. Did I understand correct? So the pipeline is mostly generated automatically when you import the framework, right?
Yes.
Yes. So how much of the stuff do you actually catch? Is it hard to like people start using a new data source? How do you deal with that?
Oh, so the dependencies that we have, these dependencies are explicitly specified within the code. So there's a self.next function within each code that defines what function to call next, and then we just walk that graph to create the complete graph for you. In terms of the input data, we also provide a lot of data libraries, data access libraries, which allow you to access data in a very efficient and quick manner. And it's just like any other data access library.
Yeah. Cool. Yeah. But you have to use like your proprietary tool too, or like your own.
Not really. Let me go back. So, for example, in this case, right, we know since build features doesn't have a dependency, it's the top level node in the graph. And we'll just start executing this graph, and this graph has this query function that will just execute this PubSQL query on a cluster.
Oh, right, yeah, okay.
Yeah, it's just a function. Yeah.
Perfect. Thank you everybody for coming. I'm a bit worried about the timing as well. Today we ran out of a little bit longer on the presentation. I wanted to have it. I think I was so pleased with everybody being so engaged, watching it. I know it's a challenging world. You know, some of us come from the background of coming into a service design background or a design thinking background, not knowing that much about the actual work going and crunching in there. On the other hand, like some of you said, it's sometimes if we get too far away from like on the actual qualitative user feedback, how are the feelings of the users, how it goes forward. Bridging that gap is actually extremely important in all of the organizations, and that's what we are working heavily to go. With that said, I actually want to allow you to have a peaceful time with drinks and your colleagues and the speakers today, and not coming to drive the workshop with this amount of crew on the place. Having to facilitate the evening hopefully with that way better and more effectively. With that said, I want to thank you everybody who joined in. I want to thank you everybody there on the lines. Even in the 360, I'm only waiting for myself to flying on top of that. And hope you enjoyed. Thank you.